Hello, Year 11. Today we're going to do about weight and gravitational forces. I know I did say we were going to do some more resolving forces stuff, but when I was having a look at the specific of resolving at an angle that was higher here, I know you do that stuff in maths, but for science, as long as you resolve on one line, then that's fine. So let's have a look at today's PowerPoint. So we're doing about centre of mass. Now you can watch that video if you want. I'm sure you've seen rugby. One thing you'll notice about the tackles is the person that's tackling the guy with the ball will try to get below his centre of mass, so that if you hit someone that's below their centre of mass, you cause them to fall over. You destabilise them rather than taking the full force of their charge. You sort of hit it at an angle. Now, I'm sure most of you have seen people do this. Gymnasts, maybe the Olympics, maybe just on adverts or something like that. This is pretty difficult. You've got to keep your centre of mass above that pole at all time. Now, what happens is every atom in your body is in the Earth's gravitational field. So every atom in your body is pulled towards the centre of the Earth. Now, you don't feel every atom in your body being pulled towards the centre of the Earth. You feel that force as one force called your weight, and it's kind of in the centre of your body. It's just below maybe where your sternum is. So that's the very centre of your rib cage, maybe the bottom of your rib cage, kind of where the rib cage ends. It's about there, just below there. That is your centre of mass. Now, if you look here, there's a few keywords. The force that we feel, okay, this is called our weight. So we feel this force, we call it weight. Now, the point where that force is, and on this woman, that point is probably around here because she's kind of side on, pointing downwards, right? So the point where we feel our weight is called your centre of gravity, or I prefer your centre of mass. If that point stays above the beam, she will stay on the beam. If that goes to the left or to the right of the beam, she'll fall off. And I'll show you why. So here we go. 3 photos. Now let's put a centre of mass on this person. It's kind of a bit off centre because PowerPoint's quite hard to line stuff up. But just imagine that's in the centre of her body. What you notice, if I draw a line directly downwards from each centre of mass, you can see the person on the left and on the right will stay on the pole because that arrow, okay, the arrow that this force lines up with this beam. And same here, the force lines up with the beam. So this person will be stable. She won't fall over. This one here, her centre of mass is way past the beam. She's touching the floor here, but her centre of mass is over there. So what happens is she will fall over. So the weight is acting straight down from the centre of mass. If the line of action down from the centre of mass is outside of the contact area, the gymnast will fall. Now that is just a scientific way of saying as if this arrow is not above where your feet are, you'll fall over because your feet are in contact with the ground. And if you were given a ticky box question, it said what is the centre of mass, you'd need to say something along the lines of the centre of mass is the point at which the mass is thought to be concentrated, or the point at which all your mass acts through. Okay. If something doesn't topple over, we call it stable. So let's have a look at a few different things. We're going to look at some cars here. So we've got a truck, we've got an F1 car, and we've got someone doing a stunt. Now let's have a look at the centre of each one of these cars. The centre of mass of this lorry can be seen to be here. The centre of mass of the F1 car, very, very low to the ground. The centre of mass of this normal car is there. So let's see if these ones are stable. Now, this one is absolutely stable because you can see the point of contact is here and here. These two wheels, as long as the center of mass is in between the two wheels, this truck will not fall over. The same goes for this F1 car. As long as the center of mass, okay, the line below it, this red line, stays between these two wheels, this will not fall over. Now, this stunt driver is only just balancing his car right on the edge, so the wheel is just there. If the driver goes a bit too far this way, the red center of mass line will be outside of his wheel and fall over in the crash. If it goes too far this way, he will land back on his two wheels, but he'll have a big bump. Okay, so this is stable, but not very stable. Whereas this probably is the most stable one. The F1 car is designed to not fall over. Now, where are the centers of mass of these objects? And we should know this from maths, right in the center. So, because it's a symmetrical shape, you can draw the lines of symmetry, and where the lines of symmetry cross, you will find the center of mass. Now, we call this here, all of these, think of these as objects on a desk. They are not moving, they are stable, or they are balanced. We call that equilibrium. Now, if we go, like I said before, if you get all the lines of symmetry, you can find that the center of mass is right where all those lines of symmetry cross. And I'm sure you've done this in maths as well. So, where the lines of symmetry cross, that is where the center of mass is. Now, you only have to have two lines of symmetry cross in the same point. You don't have to do them all. Okay, so any two. So for a regular shape, that is how you find the center of mass. Now, the next bit is the required practical, which involves irregular shapes, because finding the center of mass on a regular shape is easy enough, but for an irregular shape you have to remember this process. So, here we are. Here are some irregular shapes. You would not be able to find any lines of symmetry here, so you won't be able to find the center of mass straight away. Now, I'm going to skip over to the next one, because fortunately we can't do this practical. You might be able to do it at home. If you find a piece of paper, what you've got to do, get your piece of paper, stick a hole in one of the corners and dangle it from something. If you have a pencil or a pen, you can stick it through the hole and let it hang. What you then do is draw a straight line going down. Okay. So there, that is the way you're supposed to do it. You get a plumb line is what it's called. It's just a string with a weight on the end, and you draw along that line. If you don't have that, doing it by eye will work. Just for this purpose, we will redo the practical when we get back to school. Then, what you've got to do is make another hole. So let's say we make a hole here, and then you enter your plumb line on your draw line going straight down. Where these two lines cross is where your center of mass is. If you are not confident that it's correct, maybe the lines miss a little bit, take a third point. Maybe there. Take a third point, hang it. What you'll find is your line crosses through near these points, and you know your center of mass of this paper is there. So let's say that again. To find the center of mass of an irregular shaped object, first of all, hang the piece of card, this is a piece of card, or your object, from a point. So in this case, we've put a hole in the card and we've stuck a pencil in it and we hang it until it's just dangling freely. Then you draw a line straight down to the ground. If you've got an extra bit of string or a plumb line, which all you'd need is a bit of string and a bit of blue tack on the end, that would work. You can use that to make sure your line's straight. Now, once you've done that, this is where the center of mass is, along this line somewhere. Okay. but we need a second reference point to see exactly where it is. So what we do is we put a hole anywhere else on the card. It could be anywhere. We put it kind of 90 degrees because then it's further away, you get a more precise measurement, but you could put it anywhere, it doesn't matter. Put a hole in it, do the same thing, dangle it, draw a line straight down. Now, where those two lines cross is where the center of mass is. If you wanted to be sure, you could do it a third time. So, here are some questions for you to have a go at. Everything we've talked about is there. The extra sheet that is in the folder, and I'll show you what I mean by that. The extra sheet that is in the folder, this shows you the experiment. So you can have a look at that if it helps you understand it more than the diagram. Okay, so this shows you the experiment. So all I'd like you to do is make some notes. Make sure you write down how to do that experiment, because that's important. That is a required practical. And then try and answer those questions, please.